right, so we're going to continue with the part that we started last week, which is storage. We are now talking about different type of storage and what the technology behind the storage in cloud computing. Just let me make sure that coding the meeting. Okay, so the meeting is being recorded. It's fine. Yeah. All right, so I hope you guys can see my screen. Eh? I'm sharing this. At any time, if there's any issue with the screen, please let me know. I'd like to know what's going on. All right, so we will talk about different type of storages that we have. So when we're talking about cloud computing, I always say, guys, remember that we are talking about a large amount of data that we are dealing with. So by dealing with a large amount of data, there is a lot of things that we will need to know about storage, because storage is one of the most important things in this. So what is storage technology itself? According to you guys, when we talk about storage as storage technology, what do you think this can be? What is storage technology? What is storage technology? Guys, understand storage is about saving data, but what about storage technology? Anyone want to give it a chance? Anyone? In your own words, guys, in your own understanding, what is storage technology? All right. So when we talk about storage technology, this refers to just every method and every systems that we're going to be using in order to store and manage all our data. So the whole technology is because we will have to create different ways of storing data. And those ways, those technology involved, those are called storage technology. All right. So basically, it's all about how data is saved and how we manage those data. All right. So we have many categories of storages, right? So we have, for example, some storages that are volatile. Last week we spoke about the RAM, RAM. Those are volatile storages. It means that after a certain time, or when the computer is the power is off, the memory is lost, or the information, the data is lost when the power is off. So those are volatile technologies, the volatile storages. And then we have other storages that can be non-volatile, such as your hard drive, which we refer as HDDs. Those are hard disk drives. Okay, so and then you can have other type of storages, such as cloud storages. Okay, so with hard drives, we can have a very high capacity, and we can save our data, but the best option would be to save the data on the cloud if the your organization or the amount of data that you're dealing with is really, really big, right? So we have those are the type of storages that we have. So we can have now different type of storage in terms of the architecture that is built, because some storage are accessed through the internet only, right? And some storage are direct storage, which you're going to access directly from your computer. You access your hard drive, but you have network attached storage, which are storage that you need to access through um, the internet. Okay, so we have so that is about the definition of storage, right? And then we can have some storages when we talk about in a narrow sense or in a broad sense. So in a narrow sense, what we call storage is just physical devices which we will use to store digital information, right? So these are hard drive. But in a broad sense, we talk about physical and virtual storage systems, okay, including cloud storage. Okay, so okay, in terms of an history of storage, the whole technology behind storage have really grown through the years. So if you go in the in the past, or you look for a picture of a 500 megabytes, that's how big that machine was, just for 500 megabytes. But today we have a very small disk, small hard drive that can carry 1 terabyte of data. So as you can see, like from the 1950s to today, things have changed, and there's been really a growth in the industry, because now we have cloud storage. We can store our data on the cloud. We have very small devices that we can use for storage. So that's how storage has really, 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 really grown. So there have been a very big development in terms of storage. So we have, for example, disk on the server, where we want to access a server and collect whatever data that needs to be performed by the CPU. And that will depend on how powerful your RAM is. That will determine how fast this information can be retrieved um, from the disk. Okay. So from separation to convergence, so this is kind of an architecture how the storage can actually, excuse me, how the storage can actually be managed. Okay, so basically okay, so as networks are really really growing, and we have a lot of applications that we really need accesses to some sort of net from the network to access the data. So we have systems or architecture that we can call. For example, we have the SAN, SAN, right? So which will establish a network between the storage devices and the server, okay, to provide some storage services. So we have the SAN here that will connect the storages to the server. So this is the SAN, which is the cloud architecture. And then we have the NAS that will connect as well the storage to the server. So difference there is that the NAS will just build kind of a network between the server, the storage devices, with file systems to provide the storage services. Okay, so we know that like in 2000, I think in 2011, there was the invention of kind of a unified storage that supported both SAN and NAS protocols. That's become very popular. So storage convergence is just setting a new trend, where we have the NAS and the SAN that are converged to provide both database and file sharing services. Because you see, the NAS protocol is for file sharing, and then the SAN protocol is just putting together the server and the storage service. Okay. So just to simplify all the storage management and improve storage, improve how we're using storage, we can converge the NAS and SAN together. Okay, so you have your remember I just said today we have what we call a direct attached storage, which is the hard drive, right? So now you can have, if you have this hard drive and you have so many data, you have so many computers, there's no connecting them. So in this case now we have these storage devices which we're going to connect to a certain server through this this architecture, right? So we have the SAN. SAN stands for Storage Area Network, and the NAS stands for Network Attached Storage. So the storage area network, which is the SAN, is just a storage that can appear as a local disk to servers. It has a very high performance, and it's really suitable for things like database and mission critical apps. And then we have the NAS, which is the network attached storage, which can be accessed through certain protocols such as the NFS. You have your LAN, your internet, right? And then the advantage of this is that you're going to have a very easy file sharing across servers, so we can move the files like that. All right, so but now with the convergence of the NAS and the SAN, we can be able to share data easily. You understand? So it can move from different different platforms as well. Okay. So the next part will be scaling out, scale out, scale out. Okay, so when we talk about scale out, so the way scale out will work is that we're going to look at multiple servers, right? Just as the word says, to scale out. So we're looking at multiple servers. So when we talk about scale out, what we mean by that is that it's an architecture where you can add more servers, right? These servers as their own disk, if you want to increase the capacity or the performance of your system. So we create an architecture where we can add multiple servers that work as a network. Okay, so instead of you upgrading to a high capacity of storage and spend more on that, you can just horizontally add your disk or your servers. You understand? So you create that network in order to that's what we mean by scale out. Okay, so some of the characteristic of this obviously will be how the architecture is going to be. So when an example can be what we call an horizontal expansion. So in an horizontal expansion, we have servers with CPUs that work together with memories and disk. Okay, so in this case now, each of this component or each of these nodes, as we call them, will also contribute to the storage and all the computing power. Okay, so and then you have another architecture apart from the horizontal expansion, which can be what we call a distributed architecture. So in a distributed architecture, what we're going to do is that the data will just be spread across all nodes. Okay, so and then we have many other characteristics that can come here. But to understand, when we talk about scaling out, we're talking about different methods that will come there. We have your adding disk, right, in a network, and many other methods. Okay, so that's how scaling out works. So all these servers are called nodes. So we're going to call them node, and these are going to help us. So we have a network manager here, a management network. So these servers are going to all play together in order for us to have a product that is performing, right? So we will also talk about storage virtualization. So So in storage virtualization, this just consolidates the storage devices, which is your hard drives and everything, into logical resources. All right. So when we look at that, what we can see is that there is many ways of really increasing the capacity of how much memory you need by just using all these methods here. All right. So some of the limitation of this architecture is that you may have a performance that is limited if
sorry,
you have
sir.
yes.
The screen is black.
Okay. Excuse me. Let me just check.
Okay.
I'm just refreshing the slide here. Were you guys able to, in the meantime, were you guys able to submit the, I hope everyone was able to submit the mock exam. Guys, there's no way anyone can say they didn't pass the mock exam. It means it's someone who does not attend classes and does not read messages. Because I'm sure most of the questions in the mock exam were already in that file that I sent. So there's no reason to fail. Okay, so we can continue with storage virtualization. So, so what we do here, we consolidate the storage devices into logical resources. All right, I hope you guys can see my screen, right? Are you guys able to see it now?
Yes, we can.
All right, so what we do is we will convert storage devices. These are the physical resources, which we, instead of using them, we're going to convert whatever action they were doing or whatever functions they were playing. So we convert them into logical resources. So in order for us to have storage virtualization, and then we will have different type of of cloud storage, obviously. But the cloud storage is one of the type of the storage. Instead of storing manually on your devices, what we're going to do is we're going to actually take the all the data and we're going to save them online. But some of the challenges with cloud storage is that sometimes you want to access your data, but it is very difficult to access your data, maybe because you don't have access to internet or you don't have access to fast internet. So that becomes a bit of a problem. But one of the biggest advantage of the cloud is the capacity that you have access to. Not just the capacity, but with the cloud as well, your data are safer. You understand? So your data are safer, and you can easily protect your data against every cyber attack when you're using a cloud service, especially when it's a public cloud, which is controlled by a big company that really protect the client. That is going to be best option there. Okay, so when we talk about storage virtualization, remember I just say storage virtualization. So in storage virtualization, what we do, we're just going to take physical storage system and servers, and then we're going to control them by creating a digital version or a logical version, if you can say that. Okay, so this can help us to simplify the management of physical devices, because sometimes physical devices become energy consuming and they can get damaged and you lose everything that you have. You know, imagine if you keep your data on the cloud, if you lose your phone, you can still access to your data. But if you want to keep everything on a specific hard drive, if you lose that specific hard drive, you've lost everything. Okay, so that's how that is going to work. So when we're looking at cloud storage, obviously cloud storage will fix the issue of that we can have when we're keeping our data on a local computer, because we can lose it. And there was very important document from the company or the organization you're building the system for. So or the organization you are that you represent. But if you're using cloud storage, there is more security, but you just have to see what type of cloud services you are using. So the cloud storage uses like kind of a grid of technologies. So there is many technologies involved in a cloud service, in a cloud storage. So we have like a grid of applications. We have what we call legacy applications, and we have new applications. All right. So cloud storage will combine multiple storage devices, applications, and services. This use an highly virtualized multi-tenant infrastructure, just to provide a scalable storage resources for enterprises. So what does this mean? It means that the cloud storage will just provide all the data storage, and you will have access to those data through the internet. Okay, and when we have these applications that will work in a cloud system, this application will be what we call a grid technology or clustered technology. Okay, so some features that we will obviously have with cloud storage is that the data are stored across multiple devices and nodes, right? That's how clouds. So your data, when we say your data in the cloud, it's not like what did this person say? There's these funny videos that I watch of a minister. I don't know if anyone has watched that. I don't know from what country he is from. I don't know if it's Uganda or Kenya. Some minister that I think the minister of finance or some economy thing. I'm not sure if you watch a funny video where you say something like colleagues, money will come, you know. I don't know, anyone has watched that? That's mainly. You always talk about it's like money will come. There's what else did he say? Yeah, you know, there's another saying, say like the economy is doing wonderful. I don't know. Is there anyone who has watched that? That's me on social media. There's so many videos that's going around. Some politician, I don't know, from Kenya or something. Has anyone watched it?
Yes, I have, sir.
Yes. Sorry, you watched him, right?
Yes.
Yes. You see what's that politician was saying when he spoke about cryptocurrency. Let me see if I can get that video. When he spoke about cryptocurrencies, because of the misunderstanding of what cryptocurrency is, because for him they just told him the money is there, is in the cloud. You understand? So he doesn't understand what is, when they talk about the cloud, what is that? And then he said cryptocurrency is just money moving in the air. You see? So you get people who think when they tell them that the data are stored in the cloud, they think that it's just there. Just, you understand, they can't find it. But um, when we talk about money, not money, as he was saying, money is in the air. No, it's not in the air. When we talk about something being stored on the cloud, it's basically it's a physical location, it's physical servers, but you are just getting access to them from a distance. So the cloud is just a remote server. It's just um, uh, the cloud is just a hard drive or a storage that you are accessing from a distance. Yeah, I think I got the video. I don't know if you guys can hear it. Let me just. Cryptocurrency. Money moving in the air. Cryptocurrency. Money moving in the air. Cryptocurrency. I don't know if you guys understand the point I'm trying to raise here. It's just a misunderstanding how you find people thinking that when we talk about the cloud, it's something in the air there. No. So you need to understand this storage that we're talking about, it's actually a physical storage that we have, but you can just access them from a distance. Okay, so those storages can be configured based on an organization requirement. So based on an organization, how they want to access the data, so that's how those storages can be accessed. Okay, so we have all these files that can be arranged a certain way in a certain cloud that can be specific for a certain application. Maybe you create an AI tool that will need certain data in real time, but you can't get those data on physical hard drives. So you can get a cloud and get your data there, and you're accessing them through the internet. So um, cloud storage is one of the best option. It's actually the best option at the moment because that is the option that everyone is currently using. So you need to know that when we talk about cloud storage, we have storage devices, but those storage devices are on a certain server somewhere. They are far from you, so you are accessing them from a distance, but your data are on an actual server. So data are stored across multiple storage devices and nodes. So when we talk about storage device and nodes, the node that we're referring to are servers, right? So the good thing about this is that it allows the availability of your data. So if you leave home today, you leave your computer home, but you need to access the data on your computer, you can't do that. Why? Because it was a physical memory. But when you have data on the cloud, you can access those data anyway at any time. Okay, so and one of another advantage with cloud computing is the scalability. So the storage capacity can grow without like a downtime or something like that. You know, you have certain cloud that can give you up to a few petabytes or exabytes. So that is a lot of space, which you can't get from a physical computer there. And then we also have mentioned that the accessibility, which means that the users or the application that is requiring data from the cloud can access the data anytime through the internet, or maybe if it's on a private network, it can access that. Okay, so some of the protocols that are used for accessing data on the internet, you have, for example, the HTTP, the NFS. I mean, HTTP is what you have for with all your websites, that all your websites are using it, either HTTP, or if it's secure, it's a HTTPS. That's why you see when you type your website, you have that HTTPS thing, right? So those are the advantages of using cloud services. Okay, so cloud services is one. Cloud storage is one of the methods used a lot in AI, big data, and all these solutions like backup solutions, because you have systems, you want to do an update of the system, you back up your data on a cloud, and then you do an update of your system. Okay, so just to try and simplify the architecture of any cloud storage, so we have the users or the application. So the people requesting information from the disk or from the storage, the servers that are on a distance, those will be the users, or the application. Application, that means that a software that requires certain information from a cloud. So from there now, we will need a network access. That is one of the biggest challenges. So if you don't have access, you cannot need a network access. Network access, now we have the cloud storage. Data in the air, as the minister said. All right. So remember the benefits of using cloud, the availability of your data. There's an easy storage, data storage. You can easily share your data or collaborate with other organizations because you guys have access to the cloud. And another thing you need to note is that in terms of the cost, the good thing about cloud services is just like, instead of you buying certain computers with high disk or something like that and spend more money, it's easy for you to just subscribe for a cloud that have a method of pay as you go. So if you are only using 200 gigabytes, better you buy only 200 gigabytes than buying so much memory that you are not using. So those are advantages of cloud. So cloud storages will just coordinate multiple physical storage. Remember that those storages are physical. They are kind of in a grid or in a grid technology. That means they are set up in a certain way. They work together, and that will help you through the internet to get storage. All right. Okay, so some of the what you call this, now when you're creating an architecture where you need some disk So there will be many ways that you need to choose your disk. If you need kind of knowledge depending on what type of application you're going to be using. Today we find even people who like playing video games, the real gamers, the people who are doing it as a business. They will tell you when they are buying a certain device, they are not just buying the device because they like how the device look like. No, they will buy the device because they know the capacity of the device. And it's not always the capacity in terms of the size, right? Where you will have, for example, your 1 terabyte, 2 terabyte, and then you think that's enough. No, we also need to look at other consideration. All right. So it's very important, even if you have to create your own data center where you have your servers and everything, you need to know exactly what type of disk you need. So we have different type of disk, but there is certain indicators that you need to look at. So you have the disk capacity, you have the rotational speed, which is found only in HDD only in HDD, which means the hard disk drive, the hard drive that we have, for example, in our computers, we have a rotational speed there. How fast? Because inside that hard drive, there's a disk that rotates, but the speed at which is rotated is very, very important. And then you have the average access time for you to access your data. You know the average access time. You have your data transfer rate, and then you have your input-output operation per second, or else referred to as IOPS. So the highest IOPS, the better performance that you're going to have. So now we have certain disk type. For example, you have the SATA disk type. So this one has the IOPS of 320, the bandwidth of 200. Can somebody read for me this? Can anybody tell me what is this? Can anybody read this? Guys, you're not gonna tell me you don't. It's not a trick question. You're not gonna tell me you can't see that. Can anybody tell me that?
Sir, can you please repeat?
I'm saying, can anybody read what's that's number? Like, what is that?
Oh, it's 200 megabytes per second.
Okay, so we have a 200 megabyte per second, right? Now, is there anyone who have a second device apart from the device that they're using to join the meeting? Is there anyone who has another device with them?
Yes, sir.
All right, so just go on your browser. It can be, even if it's open Google, it's fine, on your browser, and then you can write speed test in one word, speed test, and then check your internet. Tell us what number you see there. Anybody else who can also do that? You can do that. I'm also gonna do that on my side here. You can just go anyway. It can be on Google or anywhere. You just write speed test, and then you will see there will be like a button to test your internet, and then you're gonna tell us if you see a number there. Speed test in one word. Speed test.
Yes, I have 15 megabytes per second on download and 2 megabytes on upload.
All right. Anybody else ever a different number? Everybody else has something else on their side?
I have
On download, I have 18,73 megabytes per second, and on upload, I have 10,29 MB per second.
What you said you have? What's the last number you said?
10,29 megabytes per second.
All right. Can anybody now tell me what is wrong in what they both said? Did anyone find a mistake in what they said? They both said. They both gave us the wrong information. Did anyone pick that up?
Did we
Is there
say
anyone?
megabytes instead of megabits?
Yes, yes. So they both gave us the wrong information because when you talk about megabytes, when you talk about megabyte, is when we're talking about storage, right? We're talking about storage of data. But what you've measured there is the speed of internet, which you can find anyway. It's not megabyte, it's megabit. So you need about, I think it's 8 bits to make 1 byte. So when you say you have your internet as a speed of 200, whatever, if the speed that is not megabyte, is megabit per second. So you need to note that. So those are certain information that are very important, and a lot of people make that mistake, and they will think that because your internet says you have 20 megabytes per second, you think that if you're downloading a video of 20 megabytes, it's going to take 1 second to download it, because people think this is megabytes. No, this is megabit. So you must understand, when we're talking about speed of transfer of data, the unit is megabit. But when we talk about the storage, we're talking about megabyte. So the bandwidth is how much storage is being used per second for this transfer of data. That is megabytes per second. But when we talk about the speed of internet, is megabit per second. All right, guys. So that is very important day. So finding the indicators for the disk is very important. So we take the rotational speed, we take the disk capacity, the average access time, the data transfer rate, and the input-output operation per second. So remember what I said, capacity, the unit is byte. So we can have gigabyte, terabyte, you have your USB, can be 32 gigabytes or whatever, but we always say gig or something like that. So that is the total amount of data a disk can store. All right. So that is the disk capacity, which is very important. That is very important. Why? Because remember, when you're installing certain software, they take a certain capacity in terms of certain memory on your storage. So how many applications can you install, and what type of application can you install on your device? It will depend on the disk capacity. So, and then if your disk capacity is good, okay, the device is fine. You check something else, the rotational speed. But this only applies for HDDs, like those hard disk drive, not the SSDs, right? So the HDDs is the unit is the revolution per minute. So you can find some common speed, for example, 4,500 RPM. You understand? So the higher RPM you have, RPM is revolution per minute. So the higher RPM you have, the faster the data can be accessed. All right. And then you have the third indicator to look at is the average access time. So when you think of the average access time, is how much time it takes to locate, read, or write data on the disk. You understand? That's why you will find some computers, you will be like, no, but the capacity of this computer, the disk is as big as another computer. But you look at one computer that is very slow, the other one is not slow, because all of these indicators have to match. So the average access time, it means how much time it takes to locate data on your disk, or to read or write the data on your disk, right? So this is measured in milliseconds. So this will include what we call a seek time, seek for as SEEK. So seek time, so that is what we call the time that it takes to position what we call position the reads or writes, right? So, and then we have the rotational latency, which will affect how the disk is going to rotate to those data that are trying to be read. So when you using, instead of using an HDDS disk, if you use an SSD will have a much lower access time. Okay, so an SSD will access the data in like 0.1 millisecond, but the HDDS will start from like 5 or 15 millisecond. All right, and then the fourth indicator is the data transfer rate. So the data transfer rate, which is measured in megabyte per second or gigabyte per second. So this is the speed at which the data can be read from or written to the disk. So when you look at disks such as the HDDS, so we can go maybe from 100 to 200 megabytes per second, depending also on the RPM. You understand? So, and then the last one will be the input-output operation per second, which is the IOOPS. So this is the number of read-write operation a disk can handle per second. So in 1 second, if you have multiple operations, how can this disk handle them? So how do the disk, so if you get in an exam, multiple choice, they tell you the indicator of the disk or your storage that measure the number of read-write operation in a disk. That will be the IOOPS, which is the input-output operation per second. All right, so just understand, most important thing to check when you're checking your write disk, the capacity. How much of memory the disk has. You have the rotational speed, right? Measured in RPM, revolution per minute. And then you have the average access time. And then you have the data transfer rate. And then the last one, you have the IOOPS. All right, guys. So those are the most important things to look at when you're dealing with your disk, right? So these are some examples of disk type and IOOPS and IOPS and the bandwidth sequential. So this is basically the data transfer rate. Okay, that is very, very important. All right, guys. So this will be all for today, and tomorrow we're going to start with the DAS. So this is the direct attach storage. All right, guys. Is there any question? In the meantime, when if there's anyone with a question, in the meantime, we can turn on the camera just for to take the attendance screenshots.